Hey geometry students, we find ourselves in section 1.7 and we're discussing three-dimensional figures. And here's our extensive vocabulary list today. Let's get started. So we've got a polyhedron, and poly means many and hedron means faces. So when we discuss a polyhedron, we're discussing a solid, a geometric solid with many faces. So after spending some time trying to do some hand drawing, I figured let me just get a picture from the internet that would better demonstrate what polyhedron looked like. So these are a representation or examples of polyhedron. And each polyhedron has a number of faces. If you look at this cube here, it's got 1, 2, 3, 4, 5, 6 faces. Faces would be the flat surfaces that make up the polyhedron, right? So you've got these flat faces. How many faces do you see on this box? You see a top, a bottom, left, right, back, and front. 6 faces. How about over here? This is a hexagonal prism. Why hexagonal? Well, here's a hexagon at the top and a hexagon at the bottom. Those are kind of like the bases. And so we've got 1, 2 faces there, then 3, 4, 5, 6, 7, 8. So we can see in each of these pictures we have many faces, and faces are those flat portions or the polygons that make up the sides of the polyhedron. The edge refers to, let's go ahead and give a little color. The edge refers to any straight portion where two of the faces meet, right? So these are edges, all of these are edges. There's several edges in each of these. I'm just highlighting different edges in each one of the polyhedron that we have here. So that's what an edge is. A vertex is going to be the same thing that we referred to as a vertex before when we were dealing with polygons. Here, a vertex is the intersection of 3 planes or 3 faces. If you can look, each of these vertices would be the intersection of 3 faces. So basically a vertex in this sense is a point where 3 faces intersect. So a prism has a special definition, a special quality. So when you're dealing with a prism, you're dealing with a solid where two of the faces are parallel to one another, and the rest of the faces on the outer sides of them basically are parallelograms. So for instance, you see that at the top here we mentioned this was a hexagon, and at the bottom we know that this is a hexagon down here. So those are the 2 faces that let me know that I'm dealing with a prism. And then along the sides, we see that we have parallelograms kind of connecting all the sides. So this is an example of a prism right here. This is a hexagonal prism. Over here we have a square prism, a prism with a square base. This is also considered a prism with a triangular base. Here's another prism, and here's another prism, and here's another prism. So we've got a number of prisms here, and I'm going to highlight prisms just so we can keep it in mind in this kind of a grayish blue color. So here's a prism, there's a prism, everywhere a prism. So we've got all of these prisms, noticing that the 2 end bases are parallel and the same exact congruent shape. Base, so you see what we're talking about here when we talk about base. We're literally talking about the side of the prism that is repeated on either side, right? So that's what the base is. But we can also determine or discuss the base of other figures, the base of pyramids. Here we have 2 pyramids, and this pyramid has a rectangular or a square base, and this pyramid, if you look closely, has a triangular base, if you see there. So the base refers to the bottom portion of a pyramid, the place where the pyramid will sit down, and the opposite of the pointed top, or the base could be the 2 sides that are congruent when we're dealing with a prism. So a pyramid, as you see here, is a polyhedron with a base and then triangular faces that lead up into a point. So it has a base and then it has triangular faces that lead up into a point. So that's the definition of a prism. And we'll highlight our prism here in orange to keep in mind that these guys are considered prisms. And a cylinder, we don't have an example of a cylinder here, but I think you guys might be fully aware of what a cylinder is. A cylinder is a prism, really, right? With a circular base. And so kind of like a, yeah, that's kind of okay. So that's what a cylinder looks like. It has the idea or the vibe of a prism. Though it's not actually in the category of prism, it kind of reminds me of a prism because it has kind of two circular bases, and it's almost like it stretches through in space. All right. So then we have a cone. A cone is also not a polyhedron, and therefore it's not a pyramid. But a cone reminds me of a pyramid, and I think you might be able to see why, because a cone basically starts off with a circular base, and it doesn't have a triangular. It doesn't have like a triangle. It has a triangular shape, though there aren't any faces to say that the faces are like triangles. So that's my cone. You could think of an ice cream cone. And so with that, we move on to the idea of a sphere, which is, I guess, basically a ball, right? It's a three-dimensional circular figure that is a ball. So I think you guys are familiar with that. And then we have regular polyhedron, and I'm going to write a definition for this one. So regular polyhedron is any polyhedron in which all of its faces are regular congruent polygons, right? We talked about regular polygons in the last section, and all of its edges are congruent. So we want all of the edges to be congruent. And I'm going to just show you a picture of these. This is taken from our textbook on page 68. You'll notice that we have some pretty cool ones here. We've got the tetrahedron, the hexahedron or the cube, octahedron, dodecahedron, and let's see if I can do it, the icosahedron. The icosahedron. I think I'm going to go with icosahedron on that. And so these are pretty beautiful in terms of their look, and they're also pretty interesting because they're referred to as the Platonic solids because Plato used them extensively. So Plato was kind of into them, and you can read a little bit more about that in your text, or you can also do a little bit of research about that online. So that takes care of regular polyhedron and Platonic solids, which leads us to the concept of surface area. So surface area, when we talk about surface area, we're referring to the area of all the faces of a polyhedron, or any of these shapes, as a matter of fact, all the outside area of any of these shapes. So our text says that the surface area is the two-dimensional measurement of the outside of a shape. When I think of surface area, I think of what is the least amount of wrapping paper I can use to wrap a gift of this particular shape. And so I think of totally shrink wrapping or fitting wrapping paper to any one of these shapes. And when I think about that, that to me is what, that to me is what is what the surface area is. And finally, volume refers to the three-dimensional measure of the space that an object occupies, and that's volume. So that's it for our vocabulary, which was rather extensive today indeed, but it should help us out as we look through some of these examples. And there's some really good diagrams in your book that I did pick out, so you can see a figure here. You've got the vertex, the edge being just a line, and the face being this entire shaded portion. And then we have some really good definitions that are placed in really nice charts in your text. So I would suggest you check those out and enjoy them, and also use them to kind of memorize some of the names and some of the shapes that we're going to talk about. Let's look at this number one, example 1. So in this problem, what we're going to do is we're going to determine whether each of these solids, we have a couple of these examples, are polyhedron. Then we're going to identify the solid. If it is a polyhedron, we're going to name the bases, the faces, the edges, and the vertices. So looking at this particular example, let's see what we think it is. Well, as I look at this, I see that it has two bases. They seem to be parallel to one another, and that usually indicates that we're dealing with a prism. So I'm looking at this and I'm going to identify this. First thing, I'm going to identify the solid. That's part A. I'm going to identify the solid as a prism. The second thing I'm going to do, if it's a polyhedron, we're going to name the bases. So naming the bases, I see that my bases are STQ. That's one, and then the one at the bottom, MNOP. And notice I use this little symbol here to represent quadrilaterals, RSTQ and MNOP. The next thing we're supposed to do is name the faces. Well, two faces have already been named, so I'm going to add that to my mix. But there are indeed some other faces here, like this side one and this one, this one, and this one. So I need to add all of those. So I'm going to add face MRQP and face PQTO and face MRSN, and finally face SNOT. SNOT, and I think I just spelled snot. Not good, but whatever, we'll get there. So those are our bases and faces. Let's do our edges. Our edges, CD, our edges refer to any of these segments here, and there's a lot. Let's see, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So any of these edges need to be named, so I'm going to do that quickly by first naming these little guys right here. So I named these bad boys. And now let me turn my attention to, sometimes you got to be systematic and just literally highlight what you're doing, because sometimes it's just hard to keep track of what you're doing. So I'm going to do these purple ones, ST, NO, RQ, and MP. And now that I've gotten those under my belt, I'm going to highlight a few more: RS, MN, PO, and QT. Whew, and though a bit exhausting, I think I have them all. Finally, we're going to find the vertices, and I'm going to call that part E. The vertices, thankfully, would just refer to these points here. So every one of the points that we see would be referred to as a vertex or a vertice, one of the vertices. And so I'm just going to write down the letters that we have here. And thank you for the alphabet. I just go M, N, O, P, Q, R, S, and T. And so those are our vertices for this shape. A little bit of work, but it's kind of nice to know what you're looking at. Let's look at the next part of this example. So as we look at this figure here, we notice that we're dealing with a cylinder, and a cylinder is not a polyhedron. And since it's not a polyhedron, we're not actually going to name any faces, because technically it doesn't have any faces. Though I refer to these guys circles as bases, since it's not a polyhedron, we can't really call these bases in the same sense. So there's no faces, there's no bases, there's no edges, and certainly there are no vertices. So I'm going to have to leave this one blank because it's not a polyhedron. Finally, in part C, we see we do have a shape that is a pyramid, right? This is a pyramid, and the pyramid does have a base, and that base of the pyramid is triangle ABC. And the next thing we wanted to do, I believe, is when we found the name and the bases, we needed to find all the faces. And so the faces of this triangle, of this triangular pyramid, would be, of course, the base is one of the faces. And then we've got the other triangles here, ADC, triangle CBD, and triangle, let's see, DAB. Yes, I wrote DAB. Yes. Okay, so that's happening. And then we've got D, which reminds us that we need to find not just the faces, but also the edges. And so the edges would be CB, CA, AB, and then CD, BD, and AD. Final part of this example is to find the vertices. And so the vertices here are A, B, C, and D.